What we're going to do now is transformations of a square root function. We have done transformations at least 2, maybe 3 times in the first semester. Transformations in function notation looks like this. Do you remember what the x minus 50 is going to do to your graph? This will move it to, why is it going to the right? It's minus. Why does minus go to the right? X is still a liar. What does the 2 out in front do? That's trickier. Do you remember that? Do you remember what a negative sign out in front does? Another word for flip is reflect. It'll turn it upside down. What is the minus 18 going to do? What's the plus 25 going to do? Whatever the graph is, the transformations work the same. What is the x plus 10 going to do? And what's the 4 going to do? I think we got this. So what we're going to do here is we are going to look at our square root graph. This is our square root graph. Where did this square root graph come from? So let's look at that first. Put this in the margin. Can you squeeze it in the margin someplace by that very first graph? So if I have the square root of x, that's what I'm trying to graph. So suppose I pick negative 4 to start with. What's the square root of negative 4? Do you remember what happens if there's a negative sign underneath the radical sign? Do you remember that would be 2i? Remember those imaginary numbers? That is not a real number. We're not going to be able to graph that on a graph paper because we have a real number graph. Okay, let's look at 0. What's the square root of 0? 0 times 0 is still 0. What is the square root of 1? What's the square root of 2? Take your calculator. That's probably not something you know. Look at your calculator. What's the square root of 2? It's a decimal number, isn't it? Is that going to be very easy to graph? It will not be easy to graph, so we're just going to put the pretty points on here. It's, what is it, 1.2, 1 point what? 1.41, okay. And so we're not going to use that one. We're not going to use the square root of 3. We're going to use the numbers that are going to be easy to graph. Well, what's the square root of 4? And we're not going to use 5, 6, 7, or 8 because they're not easy to figure out. What's the square root of 9? So these are the points that they put on this graph. And what it keeps going. It keeps going to the right. It keeps going up. What they didn't put here for you is the domain. The domain of this graph. Do you remember the domain is the x values? So it starts here and keeps going that way. It's a square bracket because that's a closed point right here, a closed dot. Now, not only is that arrow pointing to the right, it's also pointing up, because these numbers are getting bigger each time. And so the range is also 0 to positive infinity. And these transformations work just like the other graphs we have done before. So we're taking the transformations we've done before and we're applying it to this parent. So in this first example, we are comparing it to this parent graph. So compared to this parent graph, what happened to this one right here? Left
and down, right?
How far did it go to the left? And how far did it go down? You'll have to count it because my screen's not very good. How far did it go down? And so then I am going to put that in an equation that represents this graph right here. And so if it went left, what am I going to write? X what? Plus 5 minus 4. This shape is the square root graph. This 5 is under the square root, the 4 is not. Make sure your square root's in the right place. And in a minute, it's going to ask you about H and K and A. The H is minus 5. This is minus 4. And the A is 1. We'll talk about that some more in just a minute. Domain is, let's see, negative 5 to infinity and negative 4 to infinity. These are the numbers that show up in your domain and range. Did you add that in your notes, the H and the K? Example 1b. Compared to the parent graph that starts right here, what happened to this graph right there? Is it up, down, left, or right? Up, how far? What else? And so the H is going to be 2, the K is going to be backwards. The H is going to be 1, the K is 2, and the A is 1. So this is going to be the square root of x minus 1 plus 2. And the domain is going to be 1 and 2 to infinity. Goes to the infinity because of the arrow on the end. Compared to the parent graph, what happened to this one? Well, the parent graph starts here, and this one starts here, 1, 2, 3, 4. 1, 2, 3, 4, 5. But what else do you notice? You notice it's upside down? What makes a graph turn upside down? What makes a graph turn upside down? Negative sign out in front. And so this would be x plus 4 minus, not minus, is that supposed to be a minus 5? Did it go down? It went up. That's supposed to be a plus 5. The domain is going to be negative 4 to infinity. But turned upside down, which way is that arrow pointing? In addition to pointing right, it is also going down. down to negative infinity. When you turn the graph upside down, you also turn the range upside down. Example 2b. What's happened to this graph compared to the parent graph? The parent graph is the very first graph on your note paper. Well, here's the endpoint, 1, 2, 3, 4, 5. 1, 2, 3. But what else? It's pointing which way? The parent graph points which way? The parent graph points right, and this one's pointing left, so it got reflected, but it didn't get reflected over the x-axis. This one reflects over the y-axis because it flipped over this way and it's pointing to the left. It's going to have a negative sign in it, but where is the negative sign going to be? So this is going to be negative x minus 5 plus 3. Since it's pointing to the left, the x values are getting smaller because it's pointing to the left. The domain is going to change. Oops, yeah. I don't really need that plus sign. And, oh, I made a little mistake. You know what my little mistake is? What did I do wrong on the domain? That is a closed point right here, so that needs to be a square bracket. The range is 3 to positive infinity because the arrow, in addition to pointing to the left, is also going up to positive infinity. Remember, the range tells you left and right, the range tells you up and down. What does a number out in front do? If the number is bigger than 1, it will stretch the graph out. And so to figure out what the stretch is, this one has a 3 out in front, so it stretches it. To figure out how much it stretches it, I'm going to fill in the table. So to fill in this, I'm going to do 3 times the square root. I'm going to take this number and put it under the square root. And what is 3 times the square root of negative 4? That's going to have an I in it. If you do it with your calculator, it's probably going to say error. And what that means is this is not real. It's not going on my graph paper. So I really don't care what it is. It's not going to go on my graph paper. The next one is 3 times the square root of 0. Square root of 0 is 0. 0 times 3 is still 0. The next one is 3 times the square root of 4. The square root of 4 is 2. 2 times 3 is 6. 3 times the square root of 9. The square root of 9 is 3. Times 3 is 3 times the square root of 16 that's equal to 4. 4 times 3 is 12. So this is going to be 0, 0. This one's not going to go on my graph paper. So this graph has been stretched out taller. If there is a number out in front that is less than 1, then that number will shrink, compress. Once again, if you do 1/2 the square root of a -4, that is not real. What's half the square root of 0? That's 0. Half of 0 is still, what's 1/2 the square root of 4? Square root of 4 is 2. What's half of 2? And so then we have 1/2 the square root of 9. That is 3. What's half of 3? And then I have 1/2 the square root of 16. That is 4. What's half of 4? And those are going off my graph paper anyway. 1, 2, 3, 4, and 1. Do you see that that graph has been squished down? It is compressed. The easiest way to make the graph if you have a shrink or compressed number is to figure out your table. But on this one right here, you have the graph and you need to write the equation. So, I put my point right here in the wrong place. It's supposed to be right here, not right there. Okay, so first of all, 1, 2, 3, 4, 5. The h is -5. The k is 0. And now we need to figure out the a. The a, if it was a straight line, how would you figure out the slope? Rise over run. So if it is a square root graph, you figure out the a, rise over the square root of the run. Well, where did the square root come from? What kind of graph is this? It's a square root graph because it has the same basic shape as the one on the front of the page. It's just been compressed. So, to find the a, how far do I rise up and how far do I go over? Rise over run. 1, 2, 3, 4, 5, 6, 7, 9. Is that it? It's a square root graph, so I have to have a square root there. What's a square root of 9? So the equation is 1/3 square root of x plus 5. Domain is infinity and 0 to infinity for the